Good afternoon. Thank you for joining me today. I'm Edwin Maes. I work at Centexbel, which is the Textile Institute for Belgium, or Knowledge Center. We do testing, certification, voluntarily, and obligated, and a lot of R&D and consulting. We are currently in a project for the European Commission where we are looking into what recycling technologies are there, in which stage are there, and what is necessary to level them up to bring more recycled textiles onto the market. So what I will be talking to you or explaining to you today is a definition of recycling, a mapping, then an overview of the three main technologies, some facilitating technologies, and then the status of the technologies. So what is recycling is actually, you have two definitions. One comes from standard on environmental declarations, specifically for textiles. And that says you reprocess a material that was once included into a product. And then you can do this mechanically, chemically, or thermo-mechanically. And then you have the waste regulation, which also says that it is a reprocessing of a material, but they explicitly say that it's not energy recovery, which is very important. So we made a mapping of the technologies, and this is still in the debate. There are some technology holders that say, no, we see ourselves more in chemical, and others say, no, we are more mechanical. We made it this, but don't fixate yourself on this. This is not very important where a certain technology is. Chemically is not a dirty word, and waste is also not a dirty word. So please keep that in mind. First of all, mechanical recycling processes. Mechanical recycling processes, you can throw practically anything into that. But what you throw into is also the thing that comes out. So depending on the structure, knitted fabric is way more easy to process than a woven fabric. If you apply a coating, you make it very difficult to obtain fibers, practically impossible. So a high-level output is not possible when you have a coated fabric. You can put it in non-wovens for isolations or grind it and use it as a filling material. Like 10% elastane, if you go higher, can be problematic. Hard parts can damage the machine, so you want to remove this. The hard parts, with the heavy technology, you don't want them, or you need to remove them. What do? Actually, you shred open the textiles and you regain fibers. You regain short fibers and long fibers. The long fibers you can spin with. The short fibers you can use for fluff production. And then you have small particles that come out. If you are grinding, then you have only small particles that can be used for filling material, or what importantly, they could be used for other technologies as an input material. And this is not really done at the moment. The outcome, there's a very strong relation between input and output. If I put a garment in there, remove the buttons from a fabric that is washed over 100 washing cycles, existing out of cotton and polyester fibers, the cotton is completely destroyed due to the use and the washing, and you will have cotton dust, but the polyester fibers remain, and you can spin with those fibers. So there's a direct relation to what you throw in there and what you get out. So if some companies claim that they can have as an output 90% of the textiles you put in that are spinnable fibers, it's not always the case. We doubt those things. The advantage, it's possible on many textile products. For cotton, if you want cotton as an input, so recycled material, it's the only way. You can't recycle cotton fibers in any other way, because otherwise you will end up with a viscose fiber. And you can also do compared to the other technologies, smaller production runs. But there you need to watch out for contamination. The quality is an issue. There are technologies or technology holders who are working on that, improving the quality, but REACH compliance is rather difficult. You need a lot of testing in order to assure that you are REACH compliant, which is for some other technologies less an issue. And the uniform colors, of course, the colors and other chemicals remain on your fiber, so that is also an issue. Then we have thermo-mechanical, and later on we have thermo-chemical recycling. Actually, that's only possible on thermoplastic fibers, like polyamide, polyester, so fibers that you can melt. Not possible on cotton because it doesn't melt, it carbonizes and it's gone. You need 100% pure material. From the moment you have contamination, you get issues. So for end-of-life fashion, this is an issue because there's too much contamination of elastane, labels, prints that are on there. And often they don't know what is in there, so they have a lot of issues. And people who recycle with this technology will avoid fashion. Because they have too many issues. Also, some chemicals can damage the polymer due to hydrolysis. Compatibilizers that can help, those are chemicals that can link to different materials. So if you have polyurethane and you know that in your product there's polyurethane present, then you could look for chemicals that can make a link between the polyurethane and the polyester so that you can recycle them together, but there's a lot more research needed to facilitate this. And also the hard parts are already explained. For all technologies, you don't want them. What is the output? Pellets that you can blend with virgin materials, because if you have only recycled, you will have quality issues, because every time you heat up the polymer to recycle it, you have a degradation of your polymer. They can apply some processes to upgrade the polymer a little bit, but after a few cycles, you will need to go to chemical recycling in order to regain your material. So it's limited. You could go directly to a fiber, but because of the quantities, they don't do that. They first go to pellets and blend those pellets with virgin material. So often you will have a recycled fiber with only a certain part recycled content, so be conscious of that. Because I need to rush through my presentation, I have very limited time for questions. Please find me afterwards. Thank you. Color blends, except if they would only select green polyester, then you would have green polyester as an outcome if the colorant supports the heat, because colorants can change. But mostly they will blend in carbon in order to get a black fiber, to have a uniform color, unless for the product color is not an issue. And the decrease I already explained. What are the advantages? It's cost-effective and a well-known process. The machines are already there. And there are little emissions and water use, so I think on the environmental impact that it's quite limited. The disadvantage is very sensible to the contaminations, degradation of the polymer, the colors, and also REACH, because chemicals, if they are not volatile, they will remain in the product. So if you have a flame retardant that is not to be used anymore regarding due to REACH regulation, and it's in there, it will stay in there. So you will have an issue. That was perhaps not an issue in the past, because REACH regulation, it evolves, and what was okay in the past is perhaps not okay anymore in the future. Then the thermo-chemical recycling, we added it quite late, but actually you are going to heat up and burn your material. You can do this with any organic material, so not with inorganic materials like metals, but due to that you can also use plastic waste and so on within this technology, so you can blend in. But also there they know, for instance, that PVC gives them troubles within their process. It's not that you can put in whatever you want. Also there they want to know, is there polyamide present, because they can only tackle a limited quantity of polyamide. So it's not like, okay, now we found the technology and we can do whatever, put whatever we want in there. So it's possible with cotton, flax, polyamide, polyester. What they actually do is they heat up with gasification. You have paroles, they heat up at a lower temperature, 500, 600 degrees. And then you get out an oil fracture that is used as fuel. And you get out gases that can also be sometimes fuel, but also feedstock for new chemicals that can be used within the chemical industry or artificial material production. The difference with gasification is that you heat up at a higher temperature, 1000 degrees more or less, and then you will burn everything. You don't have that tar fraction, but everything goes up into gases, which are then used as a feedstock. So they can refine those gases within existing processes in order to get feedstocks for the chemical industry. And they, depending on what they do, you get different feedstocks. So in the atmosphere of oxygen or other gases, you get other feedstocks. So there are a lot of possibilities, and they think they have more or less 70% of your material is recovered with gasification, which is quite a high yield. And here, your feedstock is pure. You don't have contaminations. So REACH regulation is not an issue. The advantages is probably here in the future you will have a technology to recycle fibers, or there are in quantities very little in use, like aramid fibers. They are not so, the quantities are very low, so perhaps this will be a technology that you can recycle aramid fibers, for instance. There's a size advantage because you can also blend in from other industries plastic materials. So the textile is blended in with other materials. You have a pure feedstock, and you have a range of chemical products. So depending on what you are doing within your process, you can have another outcome for another industry to be used. The disadvantages is probably a higher energy cost than for thermo and mechanical, the thermo-mechanical recycling and the chemical recycling. And at the moment, there's still a risk that it will be used as fuel and not as a feedstock for the chemical industry. And also, you have a lower percent, so I talked about this, probably 75%. There's still 25% of your material that is not recovered, which is with the other recycling technologies, you have a higher percentage, even if it's downcycling. Then chemically recycling, currently there are three main things that we see happening. That is actually the viscose process. So they use cellulosic material like cotton, flax, and so on to make a viscose fiber. So instead of wood, they make pulp out of the cotton, the viscose. They're focusing on cotton, but theoretically it would also be possible with other materials. Then you have the monomer recycling of polyamide 6 and PET. And then technologies that focus on both cellulose polyester blends, two fibers, where they want to regain both fibers. Because within the other technologies, you might dissolve the elastane and then it's gone with your solvent and you focus on one material. Here they are trying to recover two materials, so that's quite important. So this is basically a viscose process. You grind the cotton, you make a pulp out of it, and that pulp is then blended in, because I didn't find anybody who has 100% recycled viscose or lyocell, depending on in which process you put it in. You can also have lyocell or cupro or another viscose type of fiber, but it's also always blended with virgin pulp. So there's still virgin wood or cellulose from a virgin source present. And not everything is possible, so not all the dyes are recyclable. There's still a lot of development needed within this process. Then you have the monomer recycling or oligomer. Actually, there they cut up the polyester, the polyamide chain due to hydrolysis or another process in order to regain building blocks to rebuild the same polymer. So polyamide 6 Aquafil is doing this already for more than 10 years. It's a very well-known company who does that with carpets, fishing nets. There are some carpets here. But for PET, now it's for food packaging bottles. It's in upscaling. But for textiles, it's not the case. With Certex, we are trying to do this. We are building up that chain. It comes later on in the presentation. And light contaminations can be tackled here. With the viscose process, contaminations are a little bit more tricky. But hard parts needs to be removed as well. And I already explained that you get building blocks to make the new polymer. Oops. Then you have the polyester cotton blend. And here it depends on, it's actually a blend of the other technologies. Or they dissolve the cotton, make a viscose fiber out of it, and you get the polyester, you pelletize it, or you use the fiber directly. Or you're going to hydrothermal dissolve the cotton. Also, again, PET is then repolymerized. Enzymatic hydrolysis, the repolymerization of the cotton, the polyester stays intact. So depending on what they are doing, you get PET pellets, fibers, or monomers. And if you have monomers, you need to rebuild your polyester. Or you have cellulosic powder or pulp, which then you can again put in a viscose or lyocell or other type of viscose. I call them also always viscose, and Lensing is then shooting at me, but actually it's basically viscose. You can make viscose out of it. You have pure colorless polymers. There was like an after treatment, that is removal of the colorant, for instance. So you after recycling, after cutting up the different blocks of the polymer, you might want to get out chemicals that are inside. So this is the after process. But in the end, you would have a pure product. REACH regulation is less of an issue. It's a technology that is suitable for degraded fibers. So they want a degraded cotton. So if the cotton is washed many times, it's very suitable for the viscose process. REACH conformity I already explained. Also, if you have done several cycles of thermoplastic recycling, you want to use chemical recycling to regain your polymers. Probably it's more expensive as the other technologies, so mechanical and thermo-mechanical recycling. Higher environmental impact, although the companies who are doing this are investing a great deal in regaining their solvents that they use, working in closed-loop systems. So please don't generalize these things. And also here you need a pure material. Even if you are cutting up the polymer in building blocks, like if you want to do that for polyester, if there's polyurethane, at the end they see that there are polyurethane flakes amongst the polyester. And if you want to then make a fiber out of it, it will give you trouble. You need to get rid of the polyurethane. So also here, it's not just throw anything into the solvent and we have a fiber back again. Then you have some facilitating technologies to solve those problems. Automated sorting is needed because every technology, they want to know what they put in their process. So you will need to sort out the textiles. Then you have some technologies where to go yarn. They are present here as well. In Belgium, we have Resortex. They disintegrate under a certain influence, so you can remove some parts that you don't want. The buttons, the zippers that you want to get rid of. And then at Centexbel, we have a project Decode where we are looking into how can we remove coatings. Because like I explained, the polyurethane can give you troubles even within chemical recycling. So a product now with a coating, you can only go to mechanical recycling, cut it into pieces and make a non-woven or something from it, actually downgrade it. If you could remove the coating, you would be able to use the backing that you use, or the basically textiles, you could recycle it. This is a status on the technologies I more or less explained. And you see TRL level it's available in the market, but sometimes limited amounts, often because it's limited, more expensive. And still there are a lot of improvements that they are working on. It's not because it's in the market that they are done. They're happy with it. No, they are still improving on the technologies. And you will see in 3 years there will be a big change. There will be many more materials available in the market. So if they ask me, do you want now an obligated percentage of recycled content in the product? I say, please don't do it yet. Wait, because the technologies are not there yet. Not all the issues are solved. But in 5 years' time, it will be a completely different landscape. I'm convinced of that. So what I wanted you to remember is you need to know what you have in order to get it recycled. So there's a big responsibility with the consumer, and we hopefully with the sorting companies. Processes need to be adapted towards the input material. So even with the gasification, they want some parameters to change them. When they have polyester, they need perhaps some other processing parameters than if they don't have it. So it depends on what you put in. Also for the mechanical recycling, they need all the machinery, if it's coated, if it's not coated, if there's Kevlar inside. They need other machines because they will break down some equipment if you put Kevlar inside. So, and R&D and trial runs are needed. If you have a certain new, not tried before, quantity of textiles, you need to do a trial run because you will encounter issues. It's not that it has already done before, perhaps there is a component in there that gives you issues. Facilitation is needed, the regulation needs to be adapted, waste regulation, content labeling. Now for socks, you can have 100% cotton socks with elastane and polyester in it, and you aren't even not allowed to mention those fibers. So even there, all the regulation that is out there is to protect the consumer and to avoid that you are being cheated upon. Circularity, sustainability is not built in any legislation, perhaps a little bit in REACH, but all those regulations need to be adapted to facilitate the circular economy. Upscaling, so there's funding needed for upscaling, more R&D, and I explained you already the obligated recycled content, what my idea is about that. So we still have time for questions.
I think so.
Yeah? Okay. You were the first. Yeah? Okay, you will find me. Anybody else? Yes?
Yeah, I have two questions, if possible.
Yeah?
So, first of all,
Can you wait? We come to you with the microphone.
Okay.
Thank you.
Okay. So, so I have two questions. Yeah, first about the recycling solution for nylon 6/6,
Yes.
because you mentioned nylon 6 and polyester. Yeah, they are common, but I don't know what is the status of the nylon 6/6 because it has different technologies.
Only 6.
Yeah.
So even polyamide 1166, because the quantities are very limited within the market, there's no focus on it. And you see that with other fibers as well. Nobody is focusing on acrylic, for instance. We blend it in with wool and in tricot, you can find it. But if you look at the total quantity on the European market, it's very limited. So you see that all the technologies are focusing on the big quantities, not the little quantities. That's why some technologies might be important, like gasification, that also those fibers can be recycled, because you need also to look at the economical feasibility. You need a certain quantity in order to run a process.
So if we have a nylon 6/6 base, it's only mechanical in at this moment.
I would say contact Aquafil and see if they can help you.
Yeah.
If you have big enough quantities, perhaps it's worthwhile to put up a production.
Yeah, we have contact already. So nylon 6 they have solution, but nylon 6/6 they don't have actually. So
and they are the only company who is doing chemically recycling on polyamide.
Yeah. And second question, maybe very short. Yeah, there are different chemical recycling technologies, but in general, what will be the LCA, the impact compared to the mechanical
We try
recycling?
to do this, but it's practically unfeasible. And my opinion on all those technologies is that we will need them all. There's not one solution, one fits all solution. We will need them all in order to get the circle round. So, like I see it, mechanically recycling will be because all the other technologies, perhaps I didn't mention that clearly enough, but chemically recycling, you need to remove the hard parts and chop smaller the textiles into little pieces so they can be processed. So for every recycling technology, you have the mechanical recycling partially as a first step. So as I see it, the people who are now sorting and doing mechanically recycling, this will probably be one hub, and they will divide the materials according to what level they are, to what the best possibility is. But I'm convinced that we will need all those technologies to move forward.
Okay, thank you.
You're welcome.
Thank you very much.
Yeah? Okay. Sorry, find me afterwards if you have more questions. Thank you.